Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And a very good afternoon, everyone. Hi. First of all, I would like to apologize because I was planning to have our tutorial session today via physical, face-to-face, but unfortunately there are some event happen. So that's why I decided that we just going to proceed with the online classes as usual. Maybe hopefully by next week we will be able to do it by face-to-face session. Okay. Before we start, okay, so just going to discuss about the test two. May I know next week how many tests that you are going to see? Berapa banyak test yang awak akan awak ada next week paper?
For now, 2, Doctor.
2 ya. This week tak ada
Tak ada.
Kita buat hari ni lah. Okay, gurau je. Okay, well actually I'm planning to also 3. Kitchen kata 3. Okay, so I planning sebenarnya I nak buat test 2 tu minggu depan hari Khamis. Tapi I heard that other lecturer also will do the same on the same week. So I decided maybe for us for this subject kita akan buat test on week 12, which is hari Khamis jugalah on Thursday, but on 16th of June. Is it okay? It will be similar like test 1, in which we are going to have it in day 1 peperiksaan 1. But the date actually for test 2, for lecturer, it is recommended for us to do the test 2 on week 10 and week 10 to week 11. So these 2 weeks actually. But by considering that we have a few public holidays and so on, so I just decided, and also we to avoid clash and you've been burdened too much with other tests, so I decided that we are going to do our test 2 on 16th of June. Yeah. So I just put this date on your calendar that we are going to have our test 2 on 16th of June. And what will be covered in test 2? Well, basically what will be covered during this tutorial, in which I'm going to cover a topic about the pure substance as well as the closed system energy balance. But for the classes, we already learned about even until up to the open system energy balance, right? But for the test, maybe the topic that will be covered, to be honest, I haven't even prepared the question yet, but I'm planning to just going to ask you up until the closed system of energy balance. But any kind of changes will be updated from time to time, yeah? Okay, hold on for a second, please. Okay, for the share. Okay, so starting from week 8 and week 9, I already kind of like started with the energy balance part, in which it started with I'm just going to give you some brief refresh balik what we have learned so far. Okay, so we already started learning about the basic concept of the thermodynamic and energy, because it's something to do with energy, changes of the dynamic of energy. So the term that we use normally, it is called as thermodynamic, in which it's, if you notice, I don't know whether you are going to take the subject next semester or the following semester, but you will definitely have another subject which is thermodynamic. Specifically on thermodynamics, next semester, if you're not mistaken, and then you have another one which is the chemical engineering thermodynamics, something like that. So thermodynamic is a very kind of like crucial thing for us as a process engineer, okay? And because of that, we start to introduce you as soon as possible, as early as possible, so that after this, you're going to get more exposure and more knowledge about the thermodynamic concept. The thing that you're going to learn later will be more detailed, but in our case, so that's why I kind of like spare two topics. The first two topics is more about theories, which then I asked during the quiz, and it's just a basic concept that you need to kind of like, get some understanding, because some of the term, it's a bit, confusing is to compare with the mass balance part. But I'm sure you are, if you are, doing your revision and you are referring to all the textbook, I hope that you will not get confused because of that. Okay, so I'm going to start with the first one, which is the introduction of thermodynamic. Some of the term that you need to understand, because these are some of the terms that will be used in the question. When I said about the closed system, what I mean by said about the open system, you should straight away know what does the closed and open system mean. Okay, so in terms of the properties, what kind of properties, and in terms of the process cycle, steady state flow, and so on. Okay, so this about the first slide. This slide is just about the theory, and then we move to the second part, which is the properties of the pure substances. Okay, still there are few theories, but I just want to highlight here is the fact that the pure substances that you are focusing here is more or less water and vapor. Because if you were to refer to the real industrial punya process, it will definitely involve sample that is a bit more complex instead of water. But in the case for us, for the sake of giving you basic understanding on how to do the calculation and how to refer to the steam table and so on, so that's why we are referring to just water. So that's why if you refer to the property table that I gave you, is all about water, steam, saturated water, saturated vapor, superheated steam, and so on. So it's all about water. So you don't have to worry when it's stated here pure substances. I'm referring to water for the time being, okay? But later, in thermodynamics, in the other subject that is more complex, then the term pure substance will be a bit different, okay? But for us, let's just speak with water and also ideal gas, okay? So these are some, okay, in terms of the phase is just to give you some understanding about different terms such as the compressed liquid, the saturated vapor, saturated liquid, superheated, so that you can at least imagine when there are some phase changes happen during the process. You can imagine in the TV diagram what happened, in which region the sample is now, because it will give you more understanding on how to do the calculation, okay? But the most important thing here is the property table, because this is something that you will refer to not only for this subject but to other courses as well. And if you notice the one that I gave you, we have like so many tables, right? Ada banyak kan, bercampur table dia. But for us, for the time being, for this course, because this is just an introduction, we're just going to focus on three tables, which is the table A4, table A5, and table A6. Yeah, one is this table A4 and A5 is saturated water. One is based on the temperature table, and one is based on the pressure table. And table A6 is about the superheated water or superheated vapor actually. And I really hope that you are going to at least print out the table, at least these three tables, so that you can do some practices in order for you to find all the data from the table, okay? This table have been prepared by researcher based on the condition of the pure substance, which is the water. So they have done their very tedious work to prepare and get the value for all of the properties, such as the enthalpy, the internal energy, and so on. So So that's why it's convenient for us to just refer to the table. And also we have the kind of like the online theme table, because nowadays it's more convenient. So, but in the test you cannot refer to the online theme table. But in the case of you want to refer to, you can also refer to the website. The link had been given here. You just put in the information, and you're going to get all the properties as what you want. Okay, so this is the link you can refer to. But I really strongly encourage you to print out the table A4, A5, and A6. And whenever you do the exercises or tutorial, please refer to this table, because it's going to really help you to understand. And during the test and also the final exam, the table will be provided, but the same table that I gave you. So, I mean, like, if you're not really familiar with, in terms of how to find specific value in the tables, then you're going to get troubles in answering the question in the test and in the final exam, okay? So this is the example of table A4. There are few properties that you can find here: specific volume, internal energy, enthalpy. The entropy part is not something that is related to our course yet, because this is more towards the second law of thermodynamics. We are just focusing on the first law of thermodynamics. So what is the first law of thermodynamics? Apa maksud ni first law of thermodynamics? Danish, can you answer? Diam. Amir, can you answer what is the thermodynamic, first law of thermodynamic tu berkenaan dengan apa? Diam je semua.
Conservation of energy, Doktor.
Okay, the conservation of energy. Thank you. Siapa? Fauzan Bagus. Yang lain diam je ha. Macam saya bercakap seorang je. Okay, so that's why the first law will be covered in this course, but later you will also learn about the second law of thermodynamics and so on. Okay, and we are also talking about the enthalpy. I give you a few examples. Okay, just a rule of thumb. Enthalpy is involving with the closed system, while for the because for the energy balance we have open system and closed system, right? For the closed system, it will involve the internal energy, while for the open system, it will involve enthalpy. So something that you should remember lah. So when you do the calculation and so on, don't get confused. Well, more or less, the enthalpy itself is the combination of internal energy and so on, but just the term that normally we going to ask in the exam. Okay. So that's about the properties of pure substance, in which the main idea is to get you to know on how to find the value here. Okay, and I also have, it's good that some of your friends asked me about how to find a value which did not state in the table. For example, like here we have temperature, right? We have 25, 30, 40. What about if something to do with if the temperature is 47.5? So there is no temperature 47.5 here, right? We only have 45 and 50. So that's why you need to also learn about how to do the interpolation calculation, in which that's something that I also have shared the video on how to do. It's very simple, and you need to also practice doing the interpolation calculation in order for you to find the value which is not stated in this table. Because if you want to list down every single temperature and so on, the table will be very long. So that's why we just going to put some range. Okay, and then for us as a researcher, what we can do is just to simply do the interpolation in order for us to find the value in which did not stated on the table. Okay, or otherwise you can just go to the website here, just put in the value so that you're going to get the property. Okay, so that's about the pure substances, and then form of energy. Okay, so the form of energy well actually is just very basic. We have kinetic energy, potential energy, and the internal energy. In which for the potential and kinetic energy, I think that's very straightforward because that's something that you've learned before. But for the internal energy, maybe this is a bit more tricky because it's involved in many kind of like, it's related to many things. As long as it's involved the interaction of molecules, that what we consider as the internal energy. So something to do with or any other energy beside potential and kinetic energy will be considered as the internal energy. Okay, so you need to know how to calculate all of these for you to find the calculation for the energy balance. Okay, for the internal energy, that's why in the previous topic you need to learn on how to find the value in the steam table, because you normally for the internal energy we have to refer to the steam table. Sorry, sometimes I use the term property table, but most of the time I'm just going to use the steam table. Okay, so people, when I say steam table, it's also referred to the same table. Okay, so the internal energy normally we're going to get the value from the steam table. Okay, so it's about the form of energy, and then we go to the open system, sorry, the closed system energy balance. Okay, so for the energy balance, I hope you don't get confused with the way we calculate the energy, the mass balance, because for the mass balance, we can afford to calculate one single process and also multiple process, you know, because the one that involved is just mass. But for the energy, we have to calculate not only the internal energy, we have to calculate the heat, the work, the potential energy, and also the kinetic energy. There are so many things. So that's why for this course, we just normally just refer to one single process, in which this one single process also involves so many energy. Instead, if to compare with the mass balance, for the mass balance part, we have the single and the multiple processes, right? For the energy, which is going to focus on one process. Okay. So basically for the energy balance is just mana eh? Sekejap. Okay. Sorry, this is not. Okay. So the energy balance question that you need to remember is internal energy, the change of internal energy plus the change of kinetic energy plus the change of potential energy is equal to Q plus, sorry, this is plus W, it's not minus W. It's well actually Q and W depends to the definition of it. If the Q is going into the system, then it's will have the positive sign, but if the system produce the heat and it will be released out into the surrounding, then it will be considered as the negative value. Similar like the work, if the work is inserted into the system, for instance, like we have a stirrer dalam satu system, dalam tank, if we introduce stirrer, so the work is supplied by the surrounding to the system, that's a positive work. But if the work had been provided by the what from the system, let's say because of the expansion, some movement happen due to the system to the surrounding, then that we call that's can be considered as the negative work value. Okay, so that's also very important for you to understand, because that will involve in the balance of the energy. Okay, for you to do the calculation. Okay, that I rasa I dah terangkan benda tu dekat dalam ni, dan there are few other terms that you also need to understand about the adiabatic process. When it's come to the adiabatic process, that means although it's a closed system, normally for the closed system, the one that had been closed is the mass, but the work and the Q can go in and go out. But for the adiabatic system, it's very perfectly insulated, so no Q will be moving in or out. Okay, so if the question stated that it's a adiabatic process and so on, you need to bear in mind lah what the definition of adiabatic. Okay. Okay, so that's about some brief about the thing that we have covered this week. I already provide you with another topics, which is the energy balance of the open system. Is more details about for the closed system. Normally, many in most situations, the closed system will not going to be involved with the potential and kinetic energy, because most of the time it's just stationary, because tak ada mass tak masuk dan keluar kan. Bila there is no movement of the mass, so we kind of like most of the time we assume that the kinetic and potential energy will be zero. So it's just the matter of the internal energy, work, and also heat. Even the work also sometimes will be zero. So it's for the closed energy is a bit easier as to compare with the open system. Sorry, the closed system is a bit easier compared to the open system. But we'll do now the tutorial in order for us to solve the question, okay, to get more understanding. So PDF. Okay, so let's just start with tutorial 5. Okay, ada yang dah buat ke? Si ada. Okay, tak apa. Okay. Today, I hope that we can cover these two tutorials, tutorial 5 and 6, because we are running out of time. By considering that I want to spare the last 2 weeks for us to go into the computer lab, because the last 2 weeks is for us to learn on how to use the software to do the material balance and energy balance by using computer. So that's why I really hope that we were able to complete all the calculation and the theories related to energy balance as soon as possible, and then we can try to use the software in the lab, because that's what the engineer nowadays are doing. It's good for you to do the manual calculation, but still, you know, by considering that you will be working in the industry, so there will be more complicated type of processes. So that's why we have been assisted by software in order for us to find the correct and proper value for each process. Okay, so draw. Alamak, benda yang saya tulis ni tak hidup pula. Boleh. Okay. Okay, good. Okay, so for question, saya tutuplah sebelum. Okay, let's just try to do tutorial 5, and this is related to the properties of pure substances. So we have to refer to the steam table. Okay, so a person cook a meal in a 30 cm diameter pot that is covered with a well-fitting lid and lets the food cool to the room temperature of 20 degrees Celsius. The total mass of the food and the pot is 8 kg. Now, the person try to open the pan by lifting the lid up. Okay, so dia nak cuba nak buka. Itulah periuk tu. Assuming no air has leaked into the pan during cooling, determine if the lid will open or the pan will move up together with the lid. Okay. Okay, so when we have some question like this, first of all, what we can do is just to draw first and get all the information before we can try to solve it. Okay, so this is for question 1. Okay, so we have like pot kan, and we have the lid. Okay, ini lid dia ya. Okay, so the weight of this, the weight of the 8 kg. Okay, sorry. So it's not W, it's mass. The mass that we have is equals to 8 kg. And now we want to know the force that is required for us to lift up the lid of the pot. Okay, so now what we can do, the first thing, okay, the temperature is 20 degree Celsius. Okay, so now with the okay, so when we want to find the force, what we can do first, we need to find the pressure. Okay, the pressure inside and the pressure of ATM here. The atmospheric pressure in order for us to find F, because F is equals to pressure times the area. Okay, so in order for us to find the pressure inside here, we need to refer to the steam table. Okay, so at 20 degrees Celsius, if you refer to the steam table, the P, how much? Boleh tengok tak dekat dalam steam table? For 20 degree F4, steam table F4, at the temperature of 20, what is the saturated pressure? Okay.
0.839.
Okay. Thank you. 2.3392. Two point 3392 kilopascal. Okay, so in order for us to find F, this is equals to the difference between PATM, atmosphere, minus pressure of inside of the pot. Okay, times A. A is the inilah area And for the atmospheric pressure, we know the value is 101.32 kilopascal minus the pressure inside is 2.3392 kilopascal. Okay, and then we have to times the what is the area, which is pi, and it's already stated that the pot have a diameter of 30 cm, right? So we can do the calculation. So at the end, we are going to get 6.996 kilopascal meter power of 2. This is meter. Okay. And then we can do this conversion in order for us to find the value in Newton. Okay. So this is equal 100 kilopascal with is equals to 10 power of 5 Newton meter power of 2. So at the end, we are going to get the value of 6996 Newton. Okay, so this is the force that is required for us to lift up the lid. Okay, so now we want to compare whether the force that we have is bigger than the weight of the lid, or the force will be smaller than the weight of the weight of the pot. If then the question asks whether it's going to move together or it's going to open the lid. So if the force is bigger than the weight, the pot akan terbuka lah. Bukan, sorry, akan naik sekali. Be lifted. Okay, so now how to calculate W pula? Okay, W is equals to mass times gravity. Okay, so that's why 8 kg is not weight. This is mass. So in order for us to find weight, we need to calculate with the mass, with the gravity. So 8 times 9.81 is equals to 78.48 kilojoule meter per second power of 2, which is also equal to 78.48 Newton. Okay, so now we have the F and we have the W. So the force is bigger or smaller than the W? So now, yeah, it's bigger, right? Force is bigger than W. So we can conclude that the pot, in the simple conclusion here, will be lifted. So, okay. This is the final answer for question 1. Well, basically, this is not involving with the process. It's just to give you understanding. Don't worry too much about it. Just try to get the understanding about how to do the calculation and when is the time for you to refer to the steam table and so on. Because in the test or in the final exam, the way I ask question will more or less related to process, instead of just giving a scenario like this. But this is just to give you understanding about how to find the value in the steam table and how to utilize them. Okay. So this is for question 1. Let's just try question 2. Okay. Water in a 5 cm deep pan is observed to boil at 98 degrees C. At what temperature will the water in 40 cm deep pan boil? Okay, assume that both pan are full of water. Okay, kalau 5 cm punya water dalam 5 cm tu boil at 98 degree, macam mana pula kalau what temperature if the water is boiled in the 40 degree 40 cm deep pan boil? Okay, so first of all, what you can do is to locate first. Okay, number 2. So we have the pot. Sorry lah, lukisan tak berapa cantik. So the first one is at 5 cm. Okay. So this is 0, this is 5 cm. Okay. and it stated the temperature, which is 98. You see, what about if we increase the water into 40 cm? What is the temperature? Okay, so first of all, we already have the temperature here for us to get the pressure. Yeah, PH, POGH. So pressure is equals to density times gravity times height in order for us to get the pressure. Okay, so what you're going to do first, we will refer to the steam table to find the pressure at this condition, which is 5 cm 98 degrees C. Okay, so if you refer to the steam table at 100 degrees C, sorry, 88, okay, we couldn't find 98 degrees C. Tak boleh kan? 88. Hmm. Susahnya nak naik ke sini. Okay. So dekat 98 ni, we couldn't find it. Okay. So that's why the one that we want to find is the saturated pressure. Okay. But we tak dapat nak buat benda tu berdasarkan value kat sini. The only that we have is 95 and 100 degrees C. And it's okay. So that's why what we need to do is to do the interpolation. Okay. If you refer here, at 95 degrees C, the saturated value will be 84.6. And at 100 degree, the saturated pressure will be 101.42. So we are going to do interpolation for that, okay? For 100 degrees C, the P saturated will be 101.42 kilopascal. For 95 degrees C, the P saturated will be 84.609 kilopascal. Okay, so that's why how to find at 98 degrees C. This is where we can do the interpolation, in which the interpolation involve, okay, first of all, 98 minus 95, the one at the lower, and then 100 minus 95. Okay, we minus this with this, the lower number, and then the highest numbers minus with the lowest one. Okay, and then we are going to calculate the difference between these two. 101.42 minus 84.609. Okay, and then plus the value as the lowest one, which is 84.609. So at the end, you are going to get the P set for 98 degrees C punya ni, condition is 94.695. 6 kilopascal. So this is what I call as the interpolation. Interpolation. And this definitely will be asked in your test and final exam. What you need to do is just to find the value at above and below the value that we want, and then do the calculation like this. so that at the end you're going to get the exact the properties that you want according to the interpolation. Okay, and this is also similar not only for saturated pressure, but also if you want to find the the specific volume for the liquid, for the even internal energy for the liquid, internal energy for the saturated, the same thing. You just need to use the same technique in which the higher the one that we want minus the lower value, and then the highest value minus the lower value, like this. So you're going to get the value which is not stated in the table, but we can predict the value for it. Okay, so when we already have the saturated the P saturated for the condition at here, we can proceed with the calculation. Okay, in which the difference, you want to see that you want to measure the difference from here to here is equals to rho G H. Okay, so the density of water is 1000, and then times with the gravity and times with the difference of distance. Okay, before this is 5, now it's 40. So 40, sorry, and this need to be changed into meter. Okay, so make sure that all the value need to be converted into the SI value, minus 0.05. So you're going to get the difference of the pressure, which is 3.433 kilopascal. So this is the difference of the pressure. So now we want to know, what we want to do is to know, because we already know difference here and here. So we want to add. Okay. So different pressure plus the saturated is 3.433 kilopascal plus 94.6956 kilopascal. It will be 98.1286 kilopascal. Okay, so after you get the new P saturated, so this is the okay, this is the value of the P saturated for the liquid here. Okay, so from here we can refer to the steam table. To get the temperature. Okay, so let's just move back to the steam table. Because now this is pressure instead of temperature. So instead of table A4, we need to go to table A5. Because it's now based on the pressure. Okay. So what is the value? 98.12. So we don't have 98.12 here, right? We only have 75 and 100 degree, 100 kilopascal. So what we need to do now, in order for us to find the T saturated there, we need to do another interpolation. Okay, so for that, I want you to do it. Let's say this is for 75 kilopascal, and for the 100 kilopascal, what is the value? 91.76. Degrees Celsius. At 100, we have 99.61. Yes. T1.61. Okay, so what you need to do, similar like this one, you need to do the interpolation. So that I'm not going to show you, but I'm just going to give you the final answer, which is at the end, you're going to get the temperature of this condition in which if we increase the water at 40 centimeter, the temperature will be 99.03 degrees Celsius. Okay, so this will be the final answer. You need to do some interpolation, okay? Okay, so this is for question 2. Any question? Okay, so now we are going to do question 3. Okay. Question 3, 1.8 meter cubic rigid tank contains steam at 220 degrees C. Okay. 1/3 of the volume is in the liquid phase and the rest is in the vapor form. Determine the pressure of the steam. Berapa pressure dia? And then the quality of the saturated mixture. The quality of the saturated mixture, this is the mass fraction. Tak boleh tulis kat sini lah. Tak tahu kenapa. Mass fraction of vapor. Okay, so the same thing, which is for this one, normally just going to use the symbol X. And also lastly, the density of the mixture. Okay, so the quality, okay, so it's already stated here. The quality X is equals to the quality, the mass of the gas divided by the mass of the total. So on. So this is, actually this is total. Empty. Okay, so let's just start with the first one, 3A, the pressure of the steam. Okay. So we have the temperature at 220. And this is a mixture between vapor and also liquid. So we need to refer to the right table, which is the steam table A4. Okay. So we have the temperature at 220. This is for question 3. Okay. The T is 220 degrees C. So if you refer to the table A4, the P saturated will be, so we need to go to table A4. At the temperature of 220. 220, the saturated will be 2319.6. Kilo Pascal. Okay, so this will be answering the first question. Because of the pressure of the steam. So we already have the temperature. Now we know the pressure of the steam. And then the second question is the quality, which is the mass fraction. Okay, so the mass fraction, this is A, this is B. Okay. The mass fraction will be the mass of vapor divided by mass of vapor plus mass of liquid. Okay, so how to find all of this mass? In order for us to find the mass, So we need to find each one first, okay? To calculate the mass of the liquid, we need to also refer to the steam table, because only with the steam table here, because here, if you notice, this is based on the kg. So this is all specific. So we can, after do some rearrangement, we can find the mass if we have the, let's say, the specific volume and so on, okay? So I'm going to show you now. For instance, like the first one, okay? So mass will be the volume divided by the specific volume of the, let's say, fluid first. We start with the fluid first, okay? So the volume of the fluid, how to find the volume of the fluid? Well, basically in the question already stated that the total volume is 1.8, okay? But it's already stated here that 1/3 of a volume is liquid and the rest is vapor form. Okay, so why we can just use that as to find it. So for the, hold on, 1/3 is the liquid and the rest also. 2/3 is the, for liquid, 1.8 times 1/3. So this is will be the volume in meter. Divided by, okay, so now we want to find the volume of the specific volume. The specific volume with 220 is 0.00119. 0.119. And don't forget about the unit, meter cube. In which you can just cancel out the unit so that you're going to get the kg at the end. So the mass for the fluid part is, for the liquid part, okay, is 504.2 kg. Okay, so this value you need to refer to table A4, yeah. Okay, what about the mass of the vapor, the gas? Okay, similar volume of the gas. So for this one, 1.8 times with 2/3 of the volume, the cube. And then if you refer to the steam table, table A4, the value for the specific volume for the vapor, so we need to differentiate between liquid and vapor, okay, is 0.086094 the kg. So you are going to get 13.94 kg. This is for the liquid part, this is for the gas part. So after you got these two value, you can go back to this fraction formula here, in which the mass of the gas is 13.94 divided by 13.94 plus 504.2. Okay, so the x will be at the end 0.027. So that means that the fraction of the gas, the quality, as what been asked here, is really, really low. The x will be 0 to 1. Okay, so this is very, very low in terms of the content of the gas inside of the without the tank. And also lastly, it's asked about the density, okay? So the density of the mixture. The density of the mixture, see, what is the formula for density? Density is mass over volume. So the mass we have 13.94 plus 504.2 kg. And the volume that we have is 1.8 meter cubic. So the density will be 2 at 7.86 kg per meter cubic. So this will be the density. Okay, so for the test and for the final exam, the question will be something similar like this one. Okay, it's about the process. You have to do some calculation. You have to find value in the steam table and so on. Okay, so please try to understand how the solution will be made for you to solve this. Okay, and then we move to the last question, which is what is the specific internal energy, okay, of water at 50 kilopascal and 200. Okay, so now we want to know what is the specific internal energy, but it's already stated the condition of 50 kilopascal and 200 degrees C. Normally, for the normal type of steam table that we refer to, it will provide only one, either the pressure or the temperature. But in this case, it's already give you two value, the pressure and also the temperature. So which table that we should use? Okay. So first of all, we want to determine whether this is the type this is the mixture of water and saturated water and vapor, or is this the superheated steam? Okay, and in order for us to, I'm just going to list it first. Number 4. Okay, so we have the P 50 kilopascal, and then we have the T, which is 200 degrees C. Okay. So let's just try to go to see by pressure first, okay? 50 kilopascal. Or maybe we can start with the temperature first. The temperature is 200, okay? It's 200. But based on here, when the temperature is 200, the pressure is 1554.9. But the one that we want is only 50 kilopascal. So we cannot use this table. What about A5 table? If you refer to 50 kilopascal, whether it's cancelled with the temperature 50. So we have 50 here, but the temperature here is 81.32. We want 200, right? Temperature there is 200 that we want. So we cannot use this one too. So this is indication that this is not a mixture between saturated liquid and saturated vapor, but instead it is a superheated steam. So for us, we have to refer to the another table, which is the table A6, in order for us to solve it. Okay, so I'm just going to give you the condition for superheated steam. And for this, we can refer to table A6. Okay, so first of all, the pressure will be smaller than pressure of the okay, for here, if you remember, okay, I'm just going to write down first. Temperature will be bigger than the T set. Okay, so in this condition, the first condition 50 kilopascal tadi kan, the temperature is very low, it's 81. So if the temperature 200, the temperature should be bigger. For us to determine whether it's superheated or not, the temperature should be bigger than the T set. The T set is just 81 tadi kan, 81 degree C. Okay. So this is 200. Okay. And then the other thing is the pressure, the temperature. If 200, but here the pressure is 1554. Okay. 1554 kilopascal. But the one that we want is only 50 kilopascal. So this is also indicate that this is a superheated steam because the pressure is smaller than the saturated pressure and the temperature is bigger than the saturated temperature. So once you kind of like encounter this kind of situation, you just need to refer to table A6. Let's go to table A6 because in the table A6 is more convenient because let's say for different temperature we have different type of pressure. Okay. I don't know why they kind of like make it in the megapascal because all the calculation will be in kilopascal. So that's why you need to kind of like change to megapascal if you want to if you want to find let's say for instance like now we have the pressure at 50. So we have the pressure at 50. Sorry, we want the pressure at 200. The temperature is 200. This is temperature. And now we want to have the pressure at 50K. So 50K, 50 kilopascal is equal to 0.5 megapascal, right? So just go here. So we have this at the temperature of 200 and at the pressure of 50 kilopascal, then we can find the internal energy, which is U. Okay. So the internal energy will be 200. Sorry. Oh, sorry. Tengok, saya pun silap. 50 kilopascal is equal to 0.05 megapascal. Okay. So 200 with the 0.05 megapascal, we are going to get the internal energy of 2660. So the answer for question 2, the internal energy will be 2660 kilojoule per kg. This is a specific the specific internal energy. This is based on table A6. It's asked about the specific. Okay, so we don't have to change to internal energy. So that's about the pure substance tutorial. I know if you're not really familiar with the steam table, you will have some time to kind of like refer to the steam table and try to extract the information. But that's why I really urge you to familiarize yourself with the steam table so that you will be able to get the information as soon as quick as possible, because maybe during the test and during the exam you don't have ample time. So that's why it's very important for you to practice to use the steam table so that you will get familiar with the information there and how to get to extract all the information. Okay, so that's about tutorial 5. Any question before I move to tutorial 6, or hopefully we'll be able to cover all these two by today? Any question? Ada soalan tak? Ke semua tak faham ke apa ni? Diam je. Okay, I assume dia semua okay ya. Sebab nanti soalan-soalan ni ditanya dalam exam nanti. Kalau tak boleh jawab, then tak boleh nak cakap apalah. Yeah, I already explained to you. Okay, so now we are going to do tutorial 6, and this is about the form of energy and the energy balance of closed system. Okay, so what I mentioned before, we have three type of form of energy: internal energy, potential energy, and also kinetic energy. Okay, and then for the energy balance for the closed system, all of this energy will be the total energy, which is equal to Q plus W, the heat plus the work. Okay, so let's just try number 1 first. There is a bell at the top of a tower that is 45 meter high. The bell weight is 190 Newton. So the bell has what energy? Boleh siapa beritahu tak? Ini energi jenis apa? Anyone want to
Potential
answer?
doktor.
Potential.
Potential. Okay, good. Yes, this is a potential energy because it's involved with the height. Okay, so imagine that this is a tower, and then we have the bell on the top of the tower. Okay, and the height, and this is 0, this is 45 meter. Okay, so we need to calculate the bell is weight 190 Newton. Okay. So what is the formula for the potential energy? PE is equals to mgh. Okay. In this case, susahnya nak tulis kat sini. It's going to change to here. Okay. So this is tutorial 6, Question 1. Okay, so we have a tower, and then we have a bell on top of the tower, and the height is 45 meter. This is the basis, which is 0 meter, and then the weight is 160 Newton. Okay, so this is a potential energy because it doesn't have any movement whatsoever. It just have the height, potential energy. Okay, so potential energy PE or EP is equal to m mass times gravity times the height. So in this case, this is actually the weight, because it's considered the gravity. So this already represent that. So 190 Newton times with the height. The height is 45 times minus 0. You have to bear in mind that we have to put some basis. Sorry, balik. Betul lah. Sorry. Okay, so this is the height is 45. So after doing the calculation, meter, After doing the calculation, you're going to get 8,550 Newton meter, in which Newton meter is equals to joule. 8,550 joule. So this is the final answer for question 1. Very basic lah. As long as you know how to calculate the potential energy. Okay, number 2 question. Okay, number 2. The roller coaster is at the top of 72-meter hill, and the weight is 699 Newton. So at this moment, the roller coaster has what energy? It's a potential energy or kinetic energy?
Potential doktor.
It's also potential energy, because it's related to the height, okay, not movement. So let's just do that. Potential energy in which mgh, and then we have the weight already, which is 6966 Newton with the height of 72 meter. So going to get 69552 Newton meter, or 69552. joule. Okay, so this is the answer for number 2. Similar, very simple, basic, straightaway calculation. Okay, and then we are going to do question 3. Two objects were lifted by a machine. Okay, betul ke? Itulah. One object has a mass of 2 kg and was lifted at speed of 2 meter per second. The other has a mass of 4 kg and will lifted at the rate of 3 meter per second. Okay. So, which object has more kinetic energy? Okay, question dia macam ni, seronok ni bila nak jawab ni. Because it has two condition. So, okay. So, let's just try to solve it. Question 3. Okay, so we have two balls. This is ball 1. This is ball 2. Okay, both will be lifted up. Okay, one have the mass of 2 kg and the speed to velocity that going to lift up is 2 meter per second, and the other one is 4 kg with 3 meter per second. So the question asks which one have the bigger kinetic energy. So kinetic energy is equals to what? Half M B. Saya yang jawab seorang Power of 2. Okay. So let's just try the first kinetic energy 1. Okay, kinetic energy 1. Sekejap saya sebenarnya tertinggal soalan ke? Tak apa. Okay, so kinetic energy for 1 over 2, this is number 1 2, and then 2 power of 2. So the kinetic energy will be 6 joule. Okay, please also list down the units and then how you get joule at the end, because in my case this is just a shortcut because I want to ni cepat. Okay, half times 4 times 3 power of 2, we're going to get 18 joule. Okay, so we have 6 energy joule. So that's why kinetic energy 2 is bigger than kinetic energy 1. Okay, so ini lagi.
Doktor,
Ah,
KE 1 bukan 4 ke?
K1 4
Kan? 2 square.
mana? KE. Which one is 4?
KE 1 doktor.
KE1. Okay. Oh, dia punya ni, dia punya weight dia ke apa?
Tak, jawapan doktor. 2
Oh,
square 2, 4, 4 dah 2,
Oh,
8,
okay,
8 bagi 4.
sorry. Terbalik. Sorry, thank you. So, 4 and yang ni betul kan? 8. Okay, so still kinetic energy 2 is 18, this is 4. Okay, and then the second question asks about which object has more potential energy when it was lifted to a distance of 10 meter. Okay, so sekarang ni dia dah naik ke atas 10 meter. Okay, 10 meter from above, this is 0. Okay, so now we want to find the potential energy pula. Potential energy, okay. So potential energy 1 mgh is equals to 2, 9.8, and then the height is 10, is equal to 16196 joule. Okay, and for potential energy 2 is 4 times Please double check the calculation later because I don't know, maybe some mistake in terms of the calculation. You're going to get the potential energy of 392 joule. Okay, even for the potential energy 2 is bigger compared to the potential energy 1 at the end. So this is the conclusion, okay? At the end. So this is to answer question 3. Okay, so question 4. A rigid tank contains a fluid, hot fluid that is cooled while stirred by a pedal wheel. Initially, the internal energy is 100 kilojoule. During the cooling process, the fluid loses 5 kilojoule of heat and the pedal wheel does 100 kilojoule work on the fluid. Determine the final energy of the... Okay, so starting from question 4, this is already about the energy balance. Yang tadi, yang sebelum ni is about the form of energy balance closed system. Okay, apa maksud energy balance closed system? Kalau closed system, the mass inside will not going to change because there's no movement of mass to in and out. The mass will remain like this. But there will be some changes in terms of the heat as well as the work. Okay, the heat and the work, Q1, Q1, and the work can go in or go out. And also it's the way we kind of like interpret the value of the Q and W, whether it's positive or negative, depends. Okay, if the heat and the work introduced into the system, the value will be positive. But if the work and the heat was produced by the system, then this is terbalik. Bukan terbalik. This is negative. So you have to be very careful to interpret whether this is negative or positive, depending to the situation. Okay, so now we have a system. Okay, answer for question 4. A system in which is a closed system, but it have a stirrer. So they have a work. Okay. So dia mula-mula dia hot fluid kan, lepas tu dia sejukkan by using a pedal wheel, ada mixer kat bawah tu. Initially the internal energy of the system is 100 kilojoule during the cooling, then the energy had been lost into heat and the pedal does on. Okay, so what we need to do is to do the energy balance. Okay, so we just list down all the things that we know. Okay, the internal energy initially, it says the internal energy because it's already very hot punya liquid is 800 kilojoule, and then the Q that had been released out, so dia cakap dia ada loss kan Q dia, so it's negative 500 kilojoule. And then we have work that had been introduced by the stirrer into the system. So bila introduced is positive 100 kilojoule. What else? Okay, so when we want to do an energy balance, the best practice is to list down the energy balance first. What is the energy balance? It's Q plus W equals to the change of kinetic energy plus the change of potential energy plus the change of internal energy. So in this case, we want to evaluate which one that is not involved. As what I mentioned before, for the closed system, normally for the kinetic energy and the potential energy, in most of situation, tapi ada juga yang ada, will be zero. In this case, it's zero because it doesn't have any. Okay, the stirrer is consider for the work, not for the kinetic energy. It doesn't have velocity to the fluid and so on. Okay, so we assume it's 0. And we only have these three: the heat, the work, and also the energy. Okay, so the energy would be Q plus W. Q is negative 500 plus W is 100 kilojoule. So the change of internal energy is negative 400 kilojoule. Okay, the change of internal energy means that U2 minus U1 equals to negative 400 kilojoule. Okay, so we have U1 already. U1, so U2 is equals to U1 minus 400 kilojoule. Yeah, and U1 we have 800 here, so 800 minus 400. So at the end, the final internal energy that we have will be 400 kilojoule. Yeah, the final energy of the fluid. Okay, the final energy of the fluid, which is here 400 kilojoule. Boleh dapat? Senang kan yang ini? Any question for this one? The energy balance? I think if you just go back slowly, you're going to get the idea, okay? So we are going to solve question 5. Write and simplify the closed system energy balance for each of the following process and state whether the heat is 0 or not, and 0 or not the heat and the work term, whether it's positive or negative. Begin by defining the system. The solution of part A is given as an illustration. Okay, so this is just to give you understanding on whether the system have any we have to consider the Q, the W, the potential energy and so on. So let's just try to do it together. Okay, the first situation, the contents of a closed flask are heated from 25 degrees C to 80 degrees C. Okay, so dah bagi pun dia punya solution kat sini. In terms of this system, kisah senang. Okay. I think the best way is to draw the process first, okay? So in this case, it's a flask that have some Q going in, okay, to increase the temperature. So let's just list down back the energy balance: Q plus W plus potential energy plus kinetic energy plus, U. So based on the situation here, which one that you think is 0? There's no movement, right? There's no movement and no height. So potential energy and kinetic energy will be 0. What about work? Any work related here? Ada tak apa-apa perbuatan kerja dekat sini? No, there's no pedal, there's no anything. So the work will be 0. So in this case, Q will be equals to the perubahan, the changes of the internal energy. Okay, and by considering that the Q is introduced into the system, it's not released from the system, so in this case Q is bigger than 0, so it's not going to be negative. Okay, this is just an illustration of how the system should work. Okay, for A. Okay, now we move to B pula. For B, a tray filled with water at 20 degrees C is put into a freezer. The water turns into ice at negative 5 degrees C. Okay, and we have to note that when the substance, okay, so we have to note if the sample, the substance to the expand due to the phase change, it will have some work into the surrounding, and if the substance is contract, it will do work from the surrounding into the system. Okay, selalunya kan, for in the case of ice, the ice from water, the ice will expand or will contract in form of ice. Soalannya, ais akan kembang ke akan kecut berbanding air? Anyone?
Dari segi fizikal ke doktor?
Ya, betul. Dari segi fizikalnya, ais akan kembang ke kecut?
Kecut doktor. Kembang.
Kembang. So, ice will be expanded kan? Compare to, kalau tak percaya, pergi letak air batu, pergi air ni. So, nanti dia punya, the volume for ice is bigger compared to the volume of water. And for that means that expansion has happened. So, work has been released out into the surrounding. Okay, kalau kita baca kat sini lah, the situation. Kalau expand, kalau the substance expand, that means that the system does work into the surrounding. Okay, so we can assume that in this case, dia dah jadi ice, the water had been turned into ice, the work had been released out. However, in the same time, the heat, the heat also had been reduced out. Kan, daripada 20 degree C, it's turned into negative 5 degree C. So that's definitely the Q already also had been released out. So in this case, tak apa, kita ni balik, Q plus W equals to PE plus KE plus U. Okay, so potential energy not available, kinetic energy not available. So now we have all of this. Okay, so in this case, the Q will be positive or negative? Because it's been released out into the surrounding. Negative or positive?
Negative.
Negative Q. What about the work? The work is positive or negative?
Negative.
Positive. Sure. Because the work should be negative actually. Oh, okay. So the work should be negative because the work had been produced by the system into the surrounding. So this would be negative. So negative Q, negative W is equals to internal energy. Sekejap Sepatutnya negative work. Okay, so in this case, this is the ni lah, the final balance lah. So the Q will be smaller than 0 and the W will be smaller than 0 too. It will be in negative value because both will be released out from the system into the surrounding. Okay, so now we are going to do number 3. A chemical reaction take place in a closed adiabatic rigid container. So a chemical reaction take place in a closed adiabatic rigid container. So apa maksud adiabatic tadi? Kalau adiabatic is perfectly insulated, so there's no Q, no work whatsoever will be going in. So in this case, the QW, potential energy plus kinetic energy plus U. So in this case, this is 0, no heat, no work. So even for that, the internal energy will also equals to 0. Although a chemical reaction happen, walaupun ada chemical reaction happen, tetapi the chemical reaction happen tu dia tak consider as part of the energy because it's a perfectly insulated. Okay, so this is what to get for C. And what about D? For D, repeat part C only suppose that the reactor is isothermal. Maksud isothermal apa? Rather than adiabatic. That when the reaction carried out adiabatically, the temperature in the reactor increase. Okay, so this is adiabatic. Now we have a system in which is isothermal. Isothermal mean that the temperature inside of this is maintained. Okay, so if the chemical reaction is produce heat, in order for us to maintain the temperature inside, we need to release some of the Q out. So Q plus W, PE plus KE plus U. So work tak ada, potential energy, kinetic energy tak ada. Now we have the Q equals to the internal energy, and the Q will be smaller than 0 by considering that had been released out from the system. Okay, so this question A, B, C, and D is just give you scenario lah for you to understand the difference between different scenario. For you to, if you kind of like know how to do the energy balance like this, and then you can straight away do the calculation. You can find the Q, the other properties that is still available here. This is just give you some of the need. Okay, so that's for question 4. We ada lagi berapa banyak ni, alamak. Question 6. An insulated rigid vessel contains some powdered coal and A at a pressure of 10 bar and a temperature of 200. The coal is ignited and the result rise in the pressure and temperature of the container of the vessel. The final temperature is 5380 degrees Celsius. Taking the vessel and the content to be the system under consideration, evaluate the increase in the energy of the system. Okay, the first is to evaluate the energy of the system. Okay, so for 6. So first of all, we just draw kotak first. It say insulated. Bila insulated, that means it's adiabatic. So it's insulated. So bila insulated, Q plus W equals to U plus KE plus PE. This is 0, this is 0, 0, 0, all are 0. So the total energy for this system at this time will be equals to 0. This is because although, walaupun it's stated here, the coal is ignited, the result arise in pressure, ada perubahan pressure and temperature of the content of the vessel, and the final temperature is 5,380 degrees C, but because it's insulated, so we just assume that although T and P increase, but no change of energy. We are talking about the change of energy because chemical reaction, which is have been directly converted into internal energy. So that's why for case A, no changes of energy happen. But let's say in case B, the insulation is now removed, the heat transfer of 50 kilojoule from the system cause the temperature to fall to the initial value 200. Okay. So sekarang ni in case B, no insulation. So some heat had been released out, which is kalau release out is negative lah, negative kilojoule. Okay. So now we can calculate Q plus W, internal energy, kinetic energy plus potential energy is 0, 0 and 0. So now the heat is negative 50 kilojoule, which is equals to the internal energy, which is also equals to the changes of the energy. So for in case of in the situation of B, the total changes of the energy will be equals to negative 50 kilojoule. What about C? Taking the initial energy of the system 32 kilojoule. So the initial internal energy 32 kilojoule. Write down the energy values after process A and after process B. Okay, kau boleh belit. So this is for C. We are talking about the changes of energy. That means the final energy final minus the energy initial. Okay. So the question asks about the final energy. That means that the changes of energy minus the initial, the energy initial. So we have the the changes of energy of negative 50 kilojoule, and the initial energy is 32. So the final energy that we want to find is negative 18 kilojoule. This is the final energy that we can obtain from the system. Okay, so that's for number 6. Okay, I'm going to be a bit rushing here, but anyway, if later just watch back the recorded video for you to do all this question. A system composed of a stone having a mass of 10 kg and a bucket containing 100 Okay, I don't want to do question 7 because I think this is a bit confusing. I haven't done it, but I think rather not, I'm not going to confuse you with this kind of question. But if you want to do it, then you are more than open to do it. Maybe this is a question that you can find on the internet. Well, basically, I can explain, but it's going to take a very long time for me to explain all of this. But anyway, just going to skip, so you don't have to worry about doing the question 7 in the tutorial. Okay, so we're going to do question 8. And this is the final question for tutorial 6. Alkaloid, a chemical compound containing nitrogen that can be produced by plant cell. Okay. In an experiment, a closed vessel, so this is the volume, has filled with dilute water solution. And this water contains these two alkaloids, azithromycin and serpentine. Okay, you don't have to worry when they give you scenario like this. because sometimes, we kind of like feel a bit scared when there are so many scientific names here and there. But don't worry, just grab the main idea in the question, okay? The temperature of the solution was 10 degrees C. To obtain in essential dry residue of the alcohol or the water in the vessel, 1 kg was vaporized. So the water is 1 kg filled in the vessel, need to be fully vaporized for them to get this alkaloid, these two alkaloid. Assume that the properties of water can be used as a substitute for the properties of the solution. Okay, so if you will refer to the steam table, normally for the steam table, is referring to the pure substance, which is water. But in this case, it has some alkaloid. But the question here stated that we can assume that this is like a pure water. How much heat has to be transferred to the vessel if 1 kg of saturated liquid initially at 10 is completely vaporized to the final condition of 100 degrees C and 1 atm. Okay, let's just first draw the picture. And I think this is the type of question that is the integration, because before this pure substance, you are referring to the steam table, and then we have the energy balance for the closed system and the kinetic energy and so on, in which we did not integrate with the steam table. But for this question, you need to know about the energy balance, but in the same time, you need to also calculate the 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 answer by using the information in the steam table. So let's just try to do it, okay? Question A. Okay, so there is a vessel. So we have the kind of like liquid that has been vaporized. Q has been introduced so that the water will be fully vaporized. The pressure is 1 atm. So, and then the T1 is 10 degrees C. The liquid is 10 degrees C before it's been fully vaporized to 100 degrees C. Okay. So let's just try to see this process. What is the energy involved? Okay. Q plus W equals to PE plus KE plus U. Okay, in this case, what are the energy that are zero? This is zero, this is zero, work is zero, because all of this doesn't involve this, okay? So we only have Q equals to the internal energy, okay? So now we want to find Q. How much is the Q? But we also don't know what is the value of internal energy. Okay, so that's why we have to refer to the steam table there. Because if you notice in the steam table, we have the internal energy kan. We have the temperature, it's already stated the temperature kan. The temperature 1 and 2 already been stated here. So based on here, we can find the steam table. And we can find the value of the internal energy. In this case, it's a specific internal energy. So just going to put it here. So 1, 2. This can be obtained from table A4. Okay, but anyway, we have to need to be very careful, okay? It's not directly that we can refer to the steam table. We need to also see the condition. This is in terms of this is liquid form. And this is in terms of the superheated steam actually. Because if you refer to table, let's say 100, 100 degrees C, but the pressure is 1 atm. Okay, so if we say here, this is not 1 atm. Kilopascal, 1 atm. Sorry, sekejap eh. 253430. So you need to find in the apa yang keluar ni. Okay. From the steam table for U1, kan keluar benda lain. Okay. For the steam table for U1, you cannot find in the what? In the steam table, because this is based on the saturated steam and liquid. But in this case, this is liquid, compressed liquid. Because if you refer to 1 atm at 10 degrees C, you cannot find the specific internal energy. So just going to give you the answer for this. This is 35 kilojoule. Okay, but definitely if the test or in the question, I will be asking the same thing. I will giving the value that you can find in the table. But in this case, just going to give you the value for here, and for U2 is 2506 kilojoule. Okay, this is, you can find it in the steam table. And so how to find this Q? Okay, now we already have the specific internal energy, which is the specific internal energy. If we time with mass, it will become the specific energy. So we just put a basis 1 kg. So here 1 kg times 2506 minus 35 kilojoule. Oh, ni per kg So this is per kg. Per kg. So we can cancel this. You are going to get 2471 kilojoule at the end. Okay. Sorry for this one. In this condition, this is cannot be obtained from the steam table that we have. This is based on the textbook, but the value had been provided by them, so that's why we can find it. But for this one, you can find for the temperature at 200 and at 1 atm, you can find the value of the specific internal energy of 2506 kilojoule. So any question like this, the pattern will be the same, but I will make sure that the value is something that you can find in the steam table. Okay, so that's about the tutorial 5 and 6. It's a bit rushing, I know, but I really hope that you are going to watch back the video, the record video later, and try to do all the exercises and the tutorial you're on. And on top of that, try to do also other exercises, especially when it comes to the steam table. Please, if you need to familiarize yourself on how to find the value in the steam table and so on. So any question from everyone? It's already 4, memang straight 2 jam kita hari ni. If no question, then that's the end for our tutorial 3. Tutorial 5 and 6. Next week we are going to have another tutorial. I'm not sure yet. I will confirm back in terms of whether it's going to be conducted face-to-face or online like this. But sometimes online is also good, because online I can record the video and you can watch it later. Later when you have more free time. But it's good also to have more interaction if you will to do it physically. Okay, but just bear in mind also, please take note that our test will be done on 16, which is 2 weeks from now. And the thing that will be covered is until this topic, which is the energy balance of the closed system. Okay, so please do your homework and please do exercises. Okay, so that's all for me. Thank you. Bye-bye. Assalamualaikum.
Waalaikumsalam.
Doktor.
Thank you, doktor.
Thank you, Doktor.